Look at any digital photograph. To a casual observer, an image is exactly what it appears to be on the screen, a flat, visible surface composed of a grid of individual pixels or mathematically drawn lines. Suspects rely heavily on this surface-level assumption. They routinely try to hide illicit media by simply changing a file's extension, typing .tif instead of .jpeg, or by hitting the delete key, assuming out of sight means the file is gone. A digital forensic investigator views that same picture entirely differently. Beneath that grid of pixels lies a deep, complex repository containing thousands of hidden data points. We are going to dissect a single piece of media evidence. We will peel back its structural layers one by one to expose the hidden truths that suspects thought were permanently destroyed. Trusting the visible surface of a digital file is the fatal flaw that unravels most digital crimes. Our first layer sits just beneath the visible pixels. It relies on a format called EXIF, or Exchangeable Image File Data. When a digital photograph is taken, the camera captures situational context alongside the actual light hitting the sensor, automatically embedding invisible metadata tags directly into the file structure. These unalterable tags quietly document the camera's specific make, the model, the device's internal serial number, and the exact date and time the shutter was pressed. If the device has GPS capabilities turned on, the EXIF section also records geolocation data. The precise latitude and longitude coordinates are permanently tied to the file, mapping the photograph to a physical location. This metadata layer is fragile. If a suspect downloads a photo and converts it from its original RAW format into a different file type, that transfer can strip away or corrupt the EXIF data completely. Intact EXIF data transforms a passive photograph into an active digital witness, capable of placing a specific device and its owner at an exact location and time. Suspects frequently attempt active obfuscation. They will intentionally change a file extension, hoping to disguise illegal media as an ordinary system file, so standard forensics tools ignore it. Investigators bypass these fake extensions entirely. They look past the file name and examine the file's raw hexadecimal code. Every file format possesses a unique hexadecimal fingerprint built directly into its header, the very first sequence of bytes in the file. This hexadecimal editor view reveals the truth. In the lower half, the value FFD8 and label JFIF definitively prove this is a standard JPEG. In the upper half, an offset of FFE1 and label EXIF confirm an EXIF image file. Suspects use this structural reality to their advantage through steganography. They substitute the least significant bits of an image file's code to hide secret text messages inside the graphic, leaving the visible picture completely unchanged. Raw hexadecimal code serves as the ultimate source of truth in an investigation. The code cannot lie about its structure, stripping away any disguise the suspect attempts to construct. Often, a suspect simply deletes the media file entirely and empties the system trash. Deleting a file removes its entry from the drive's index, but the data itself physically remains on the disk in unallocated space, or intentionally hidden partitions, until the operating system eventually overwrites it. To recover this missing evidence, forensic examiners use a process called data carving. Forensic software hunts through the unallocated void, searching for those specific hexadecimal headers and mathematical data patterns. Once identified, the program pulls the scattered file fragments out of the free space and stitches them back together. File deletion is merely an administrative illusion. The physical evidence remains fully intact, waiting to be carved from the dark spaces of the drive. Finding hidden or deleted evidence is only the first step. For that evidence to be admissible in a court of law, investigators must mathematically prove the data hasn't been altered during the recovery process. They do this through hashing. Hashing algorithms process the contents of a file to generate a unique, unalterable digital fingerprint. If even a single bit of data changes, the resulting hash value changes completely. Investigators filter their massive drives by comparing these hashes against the known file filter database, a registry containing the exact hash values of known illegal files. For those fragmented files carved out of the void, examiners use Blockwise hashing. This process builds a dataset of hashes for individual sectors of the original file, allowing investigators to verify that the reconstructed pieces are exact matches. Digital evidence is highly fragile if mishandled, but when properly secured and mathematically validated, it is inescapable. Every digital image is just the cover of a much deeper, undeniable record.